Today we have Maksim Lin, the Magic Jigsaw, the process of designing an open source / hardware music tracker. Round of applause.
Thanks everyone. Thank you for making it back after lunch on the last day. I appreciate you all coming. Just to give you a little heads up, I do have a prize at the end for the best questions, so think of questions as we go. And I'm going to try and go really quick so there's plenty of time for plenty of questions. So my talk's called The Process of Designing an Open Music Tracker, but really I could have named it Running an Open Source Business on Open Source, because what I'd like to talk about is really all the giants that I and my collaborator stand on in building our new product, the picoTracker. Now, I promise it's not a sales pitch, but I will be talking about what we've come up with. So the agenda for today is I'm going to talk really quickly about what trackers and specifically the picoTracker is, because it's a niche of a niche of a niche. So I find most people don't even know what the term is really talking about, so I'll cover that. I'll talk about hardware. I'll talk about firmware, aka software that's harder than other types of software. Documentation, hopefully making music that's not made by me because I'm an engineer, not a musician, and then basically everything else to round it out, and then hopefully questions. So what is a tracker? So some history. Basically what you're looking at there is the very first one, the OG, the Ultimate Sound Tracker, which was done by a chap called Karsten Obarski, probably got the pronunciation wrong, back way in 1987 for the Amiga. I think it was actually the Amiga 1200, I think, not the 500. So it was one of those first home 16-bit computers. Gained quite a following in what was called the crack and later demo scene, because essentially there was quite a thing back then of creating workarounds for copy protection that games publishers put on their games to stop people copying them, but other people just basically wrote workarounds to remove the copy protection. But what they started doing was putting in little animations and then sound to go with the animations and music while the copy protection was being removed. And these end up being called crack screens, and they would often use these programs called trackers to write the music. Now, I still haven't told you what a tracker is. That first little point there is kind of like the really 5-second TLDR. It's a way of composing electronic and sequencing electronic music. I'll talk a bit more about what the workflow entails, but essentially that's it. And it was meant to run on computers, like I said, early 16-bit computers that were very by today's standards, very slow, not much memory. So it was a way of getting the most out of very limited hardware at the time. Yes, I suspect there may be people here who were not born in 1987. So this was a while ago. Now there's also, if anyone finishes this talk and goes, I want to actually learn all about trackers as Max didn't tell me about, there's a fantastic video I have linked in my slides on YouTube, which gives you the full blown history. It's really well made, worth a watch. So let's fast forward a decade or two. Then around 12 years ago, they started putting out these little embedded Linux device, or so they, like Chinese and South Korean manufacturers, started putting out little handheld embedded Linux devices meant to run emulators for the old style games that ran on computers I just talked about. So Commodore 64, SNES, Sega, all those. And a chap by the name of Mark Nostromo, well actually that's his stage name. As you'll find as I go through a talk, there's lots of stage names because a lot of this was done by people who are musicians and they seem to like stage names, kind of like people's handles online these days. So he created a program called LGPT, Little GP Tracker, which itself was modeled on a homebrew program called LSDJ, which amazingly actually people outside of the whole area of chiptunes have sometimes heard about, which ran on a Game Boy and was again itself a tracker, but with quite a different workflow from those original trackers because it was running on something that was a games machine. It was a handheld, the Game Boy, the original Game Boy. And so when people started making these embedded Linux devices that were meant to emulate those things like the Game Boy, it was a natural fit for him to write a program in that same style, in that same workflow that would run on those devices. However, he also, I think, was developing on a Mac, and then he made it compatible with Debian, or the Debian as it was 12 years ago, because it made his life easier to develop. So it was actually a cross-platform app almost from the very beginning. It was proprietary from the beginning, but he soon open sourced it, and it's basically been available for the last decade and a bit as a under, I think it's the MIT license, and it's still on GitHub. Hasn't been maintained for over a decade, but there is an active fork of it on GitHub that is being actively maintained. I think somewhere there might even be one of the contributors to that fork in the audience. But yeah, that's still going, and it still runs on a whole plethora of more modern devices, both desktop and handheld games machines running Linux. So, enough of that. What's the picoTracker? Well, it started as a hobby project port of LGPT by a chap called Democlod, or his name's Francesco. And what he did was he thought it would be an awesome challenge to get that Linux app that was meant to run on things that never had less than 16 megabytes of memory on a Raspberry Pi Pico, which is a little board from Raspberry Pi, which is not the Raspberry Pis, it's actually a microcontroller board, which is basically meant for embedded use, and it's got a whopping 250 kilobytes, not megabytes, kilobytes of RAM. It can use up to 16 megabytes of flash, but normally only it has 8. And essentially, he did the amazing job of porting that software that was meant to run on something that had hundreds of times more RAM onto it, and he got it working. And this blew my mind. I came across the project. I was just absolutely stunned. I had to start using and participating because I'd been kind of messing around with similar sort of projects, but never in my dreams did I think someone could get that code base working on such a tiny device and actually working reasonably well. So that was how I got involved in the project. You can see here, sorry, I'll try and use the laser thingamajiggy. This is not the original prototype he built, that's the original prototype I built because it's got that amazingly bright yellow filament that I love printing with. So that was like my kind of introduction to the project, building that, and being a software guy most of my life, I actually made it work. You do not want to see what's inside there. There is like about literally 50 or 60 short wires all soldered together onto various pins. There was no PCB. These are all like separate components that I all just wired up together with different dev boards. It looks horrible, but it actually worked. So this got me hooked. And so I became a contributor. And I actually ended up doing a workshop at the last Everything Open where I helped people, about a dozen or so people, actually build their own ones from kits that I put together, because I found out that people found it much easier if they didn't have to go order parts from everywhere. And by this stage also, you can see this is not the same unit I just showed you, because Francesco had actually created a portable model, which was a custom PCB that he designed himself, not based on the Pico, but based just on the microcontroller, the RP2040, and a completely custom board with a DAC, optocouplers for the UART that goes out to the MIDI, all the stuff that was basically required, but he just built a custom board versus the crazy wiring together of multiple dev boards that was the first prototype. And it was open, fully open hardware. He published all the KiCad design files on the GitHub, the STLs to print the case. I found some open source designs for those buttons, but the thing is those are just for Cherry MX compatible low profile switches. So you could basically buy them anywhere because they're so common on mechanical keyboards. Thankfully, gamers love their mechanical keyboards, so there's vendors galore who sell them. But I had to go at printing some just to label them because some people said it was a bit hard to use it without actually knowing what each key was. But to be honest, like if you use it enough, muscle memory kicks in. So then we move on to the end of last year. I keep forgetting it's sometimes 2025, but end of 2024, more things. So we created, well, when I say we, mostly Francesco, created an update of the PCB design to remove most of the soldering, because we found that especially soldering a flex cable with 0.8 pinch 0.8 millimeter pitch was quite hard. And just soldering in general put a lot of people off. So now the new design, the only thing you have to do is solder on the the mechanical key switches, which are just basic through hole. Most people can handle just that level of soldering. Everything else is with connectors, the LCD, and it's like, as you can see here, there's two PCBs. The main PCB here, and the second PCB for the key switches. Actually, there's a third PCB because instead of 3D printing it, now the bezel we actually made out of the PCB material. So that made it a lot easier as well because that was one less thing people needed to worry about 3D printing. So also there was upgrades with a better LCD, better battery. We started using a PS5 battery, which is really readily available and more, depending on where you get it from, between 3 and 5 times the capacity of the original little LiPo that we were using. So there were lots of upgrades. Plus, I spent a lot of time working on a new V2 firmware with like literally hundreds of bug fixes, probably around a dozen new features, and support for instance, the new LCD, which was a different display controller than the old one. And so that was all done by basically Christmas, New Year's. Oh, and of course, probably the main thing I should mention is that we decided to found a company and work full-time on this. So for the last few months, this has been my full-time job. I started off this was just the sideline hobby, and somehow it's actually become my full-time job, and I get to work on this every day, the whole day, every day, which is pretty awesome, to be honest. But we're still completely open source. The design files for the new case, because the PCBs changed just slightly, is up on GitHub, so are the KiCad files. So we're still all completely, even though we are now selling these as a kit, though I've done the bad thing of turning up at a conference to spruik a product that is currently sold out because did not anticipate how popular it would be. Hopefully within a week or two, there will be more stock in the shop for people who do want to buy the PCBs. But of course, you can just download the files, go to PCBWay, JLC, whoever, and make them yourself. There's, nothing stopping you doing that. And finally, kind of moving almost a little bit into the future, we've kind of subtly, or not so subtly, announced that we're working on a new, or have been working on it for a little while, a new next model called we've christened the Plus, the picoTracker Plus, and it's going to be a fully assembled device because we've also realized that a lot of people don't want to build, and in fact we've had like just constantly people emailing us, DMing us on Discord saying, I can't build it, or I don't have the resources to build it, could I just have you build one for me, or could you tell me someone who will build it for me? So we've decided to make the next model just fully assembled. But that was quite a big decision because there's a lot of things that go into that, which I'll talk about in a second. Plus there'll be lots of upgrades, which I'm not going to tell people about just yet, for the new model as well. So hardware, as people like to say, is hard. I'm someone who was an EE but spent his whole career writing software. So for me, it's been especially hard. There's lots of stuff to do. The schematic design, PCB layout, selecting and help us sourcing components. That's a whole thing in itself. Designing the case, the enclosure, 3D printing, getting the 3D printing to be half decent. Then there's also laser etching. Why you want to do laser etching? Well, one of the reasons we want to do it is certification. I'll talk about that in a little bit, but that's just more stuff to do with hardware. So this is where I get to talk about all the giants' shoulders that we're standing on, because we could not do this without all the amazing open source tools that are available. It literally is the golden age for someone who wants to do not just open source software, but open source hardware. Well, I guess you could even do proprietary hardware with open source tools, but the open source tools are amazing. KiCad, I think other people have talked in other talks about it. It's just fantastic for everything to do with circuit design. We use FreeCAD, which in the past has been less than awesome, but recently they did their 1.0 release and fixed the most annoying bug that they had where designs would break when you went back and changed things. It was called the naming problem. Now it's not much of a problem anymore. So it's been much, much nicer to use it in the last couple of months versus the older versions. For 3D printing the actual designs, I've got a Bamboo printer, so I use Bamboo Studio. It's their fork of another open source slicer, but their fork is still open source because it's linked to license. In terms of debugging hardware, which I'll talk about in a little bit, I've been using something called SIGROC PulseView, which is like the application that can talk to various hardware logic analyzers. And there's also like a DSView, which is one company's fork of that for their specific logic analyzer, which I've ended up using most recently. So doing the actual design, you've got then the prototyping and testing the devices that actually get built. Here's just another kind of recap of some of the tools I've already mentioned, but the main things that are here that went on the previous slide are things like having the bus pirate for various serial protocols. We seem to live in an age now where serial has won the world, though all those 8-bit or whatever parallel buses are not really much of a thing anymore. I don't think we've got anything except serial in our device, so it really helps having logic analyzers, even fairly simple ones. For the first time in my life since university, I'm using an oscilloscope, and there's also TinySA and something called a temp cell, which I'll talk about in a little bit. That's all to do with signal analysis or checking for signal emissions from your device. I'll get to that in a little bit. But again, apart from that Rigol oscilloscope, which is pretty much all proprietary, except it's on Android firmware, so people have been able to already hack it and disable artificial limitations that make it not work as well as it should. Basically, that's about the only proprietary thing. Oh, sorry, and the TinySA spectrum analyzer, its hardware is proprietary, but basically they open source the firmware and all the documentation and everything, so it's all mostly open source in that list. I thought people would like to see just pretty pictures of things, or maybe not so pretty pictures of things. So when I talk about 3D printing, I have done a lot of 3D printing in the last 12 months, because even something that looks as simple as the picoTracker, this little fairly rectangular case, turns out there's a lot of things that can go wrong, especially when you're printing like little cutouts for power buttons and USB. There's more examples of the SD card slot not being right. Here's some of the different variations I tried printing. This one is actually a contribution that we got from one of our early adopters. So a lot of 3D printing involved. Cornstarch, because PLA, for those of you who don't know, PLA, the kind of easiest filament to work with a 3D printer is, as far as I know, cornstarch. And I try to avoid using the stuff that gives off the noxious fumes, because I don't yet have a proper extractor, and the 3D printer is basically 1 meter away from me in my workspace. Debugging, luckily the RP2040 comes with a way of being debugged by itself. Like you can actually use one RP2040 to debug another one. You just basically put some firmware on it that implements something called a pico probe. And so what you can see here is like an actual Raspberry Pi Pico sitting there connected with a like with the little headers that I've got there on one of my debug picoTrackers. And it's a real pain in the bum to do that, to be honest. Like those header wires constantly fall out unless it just stays in place the whole time. I've got a messy workspace. I'm constantly moving it backwards and forward. It's a real pain. But luckily I have a super great collaborator who's excellent at hardware design, who's doing all the boards, the originator of the project, Francesco. And he said, well, why don't we just put one on our board itself? So now this, I've got one here. This is my new dev board, which is actually, like, you can barely tell it's any different from like production units, because essentially what he did was he put the second RP2040 and related electronics and the USB for it right down there in the corner. So now it's beautiful. All I need is one USB cable. I'm sitting there even on the plane, in the airport. I'm actually doing my development debugging work without all these cables all over the place. I would never have done it with just the Pico probe connected with those little cables. So more stuff like, oh yes, this was the fun of, we were trying to do some initial readings for voltage and at various temperatures. So unfortunately, I didn't have a thermal camera, so this was like the hacky way I was trying to do it. It doesn't work very well. Like, I don't recommend this setup. I probably will end up getting a thermal camera. I mentioned Logic Analyzer before. This is the latest setup I've got now. This is giving the game away a little bit because this is the development board for the new model that we're working on. It's not really the new model. It's mostly like the case of the old model, but it's got some of the new hardware that we're using. So that I got to do the bring up of that. And as you can see, I noticed that there was a problem with the I2S audio output not working, and I had to debug it for a little while. Couldn't figure it out what was happening, so I finally had to break out the Logic Analyzer, connect up the probes to the various output lines, and realize that my almost infallible colleague had actually just switched two of the wires around, so they weren't as labelled on the original PCB design. Once I knew that, of course, it was super easy to change things around, and it worked perfectly. But yeah, I don't think I would have been able to figure that out very easily if I hadn't had a Logic Analyzer to hook up. I'm just proud to have an oscilloscope. First time like in 20 years I have my own oscilloscope. I haven't really had much use for it. That was just me checking a voltage line, but I wanted to include that. So again, there's a lot of people here I know who are actual proper hardware engineers for whom this is all like, 101. Oops. Oh, my apologies. This is all like basic stuff, but for me, I had to learn a lot of hardware stuff or relearn a lot of stuff from scratch. So having to like inspect tiny SMD components, at my eyesight's not very good. I'm quite short-sighted and astigmatic, so like seeing little things for me is hard at the best of times. I rigged this up with I got one of these cheap $30 web USB microscopes, in quotes, microscopes off Amazon. Works okay for inspecting stuff, but then I actually tried to do some SMD soldering, not even that complicated. The latency was just like impossible. Like you basically move your hand, and it's probably only maybe 500 milliseconds later or something, less than a second that the latency is, but that's enough it just feels like you're controlling a robot versus your own hand. So I spent a bit of time lately to kind of upgrade. So basically what I had was an old LCD from a Kickstarter from years ago that it was easy to plug a Raspberry Pi into. So what I also found in my spare parts drawer was a Raspberry Pi camera module I never ended up using for whatever project I got it for. So all I did was put it here onto a little stand which I got with that original USB webcam, and now it works brilliantly, zero latency. Like I was amazed because I thought it's just a really cheap like camera module and it's just a Raspberry Pi Zero. Surely this is not going to be much better than what I got, because it's maybe an extra $10, $15 for all the parts, even though I had them lying around. No, this is like night and day. If you want to do soldering that's magnified with like SMD parts, don't buy those awful web USB things. Just get a Raspberry Pi. Apparently even the cheap camera modules work fine. Set it up. The only thing you have to do is like twist the little tiny fixed focus lens so that it's kind of like in macro mode. The focus is for macro, and like you can see, it works beautifully. That's even without like the ring light that I've now got to put over the top of that. It's just like with ambient light coming in through the window. So I'm taking too long with all these things. So I'll quickly go through some of the other slides. Spectrum analyzer. I haven't built it yet, but this is called a temp cell. What it does is it basically pretends to be a giant coax cable. You put your board or whatever you're testing in that bottom bit, hook up a spectrum analyzer, and you get a rough idea of how badly, or not so badly, your board is emitting RF. And this is required because you basically don't want to send your device to a lab to get FCC certified if you're not fairly sure it's going to pass, because most labs will just charge you, whether you pass or not. We found one that has told us that they will let us retry, but it's not something that you want to like keep getting wrong. So this is going to be my way of checking to see how bad our emissions are, hopefully not too bad. This was a quick slide about why we chose the 2040. I probably don't need to go into much detail about it, except like to say it's an awesome microcontroller. I'd recommend you using it. It's quite a challenge to get our application working on it, but it's, in general, fantastic. And the best thing about it is the community. Like, it's an awesome community. There's lots of much better microcontrollers from other companies, but the Raspberry Pi Foundation have done an awesome job fostering community, and I have found that invaluable. So I'd rather have a harder time getting some things to work because it's a more limited microcontroller than going for a better microcontroller from a vendor who basically doesn't want to know you unless you're ordering a couple million for some new car that you're building. Basically, this is what's inside a picoTracker. Like, I listed all the things here. It's probably not important, like, to go into all the details, but that's roughly like the, the checklist of hardware that's in it. The main thing I wanted to say was I'm very proud that my collaborator designed this from scratch. There are other will not be named products that are very similar to ours, where they've just used a daughter board with an existing microcontroller already on it, and they've put that on their PCB that they designed. But a lot of the stuff they just got for free, basically, from using the daughter board with the microcontroller already on it and all the associated electronics. I'm quite proud that ours is completely custom from scratch and, of course, fully open source. These are all the physical bits that are in this is the V1 picoTracker that we built last year. I think there's one or two people maybe in the audience who were there in Gladstone when we did that, which was a lot of fun. This is the current V2. As you can see, it's quite similar, but as I said, the main changes are that there's a few extra connectors, so you don't have to solder anything except the keys, and the battery is now, like I said, out of a PS5 controller, so super easy to find, whereas even I had trouble initially finding vendors who were selling the first battery that we were using. So what's inside the Plus? Well, I think I've given the game away by a few slides ago. It's going to be based on the RP2040, which is the new version of not the replacement, but the improved version of the 2040 from Raspberry Pi. It's basically double the speed, still dual core, double the RAM. It now has a floating point unit. It's just better all round. And it's basically exactly what we were hoping we could have out of the 2040, and now we've got it for our new model. So I have heaps and heaps of ideas now of things that I can do that wouldn't have been possible with the 2040 that now are like within the realm of possibility. So that's all the hardware. Firmware. So we built that firmware using the Pico C SDK, not Arduino, not MicroPython, just the raw C SDK, CMake, Ninja, Python. Those are all the things that are part of this SDK. We're on, yes, for those of you who do this sort of thing, 12.3 is not anywhere near the latest version of GCC, but we just haven't had time to upgrade. We've started doing some tests, so it shouldn't be too bad, but especially we have to upgrade like some of our dependent libraries because we're using old versions of them, and they definitely do not support anything past 12. So we need to go on to new versions of dependencies before we can upgrade. Debugging firmware, wow. This, for a person who's done mostly mobile development for a better part of 10 years, or better part of 15 years, was a revelation. So for those of you developers in the room, and keep your hand up if you use a debugger of some sort. Excellent. Have you ever thought about only having a maximum ever of 4 simultaneous breakpoints? Because, oh yes. Perhaps it's worse on other microcontrollers, I don't know. But that's the maximum number of hardware breakpoints that you can have when you're debugging on the RP2040. And unfortunately, the tooling, at least that I'm using, a combination of VS Code and OpenOCD and GDB, basically crashes as soon as you add a 5th one. It doesn't say, warning, we can't support anymore. It just crashes. So I've learned to keep a very close eye on how many breakpoints I have when I'm debugging, and it's super, super annoying at times to be limited to 4, but at least it's better than 0. So I have to say, you just have to live with these things, but sometimes it's not fun living with them. So I've also put the logic analyzer here, even though I'm talking about firmware, because like I said, sometimes I found that the only way to debug a software problem is actually using a logic analyzer and looking at the signals coming out of the hardware versus trying to just use the debugger in your code. One thing I'm quite proud of is that the picoTracker has now a remote user interface. I'll explain in a second why it's useful, but basically what it does is it mirrors. It's like in the old days if you used VNC, or maybe even still today, people do VNC or Remote X11. It gives you a mirror of your screen, which is, as you can see, or as you maybe can't see, is quite small physically. You can have a mirror now on your desktop computer as big as you like, because it just works as a web page in a web browser using a thing called Web Serial or Web USB. I forget the spec's name, but unfortunately only Chrome and Chrome-based browsers implement it. Firefox and Safari have chosen not to implement that because it's just a draft standard. It's been around for, I think, 10 years, so it's a very old draft, but only Chrome-based browsers implement that. But it means it's a really nice way of having a serial UART connection to any sort of embedded device like this, and in this case, I'm using it to mirror the UI, which then you can just basically open a web page, connect it up, see it. Documentation. Everyone loves documentation. I love documentation. I also like yak shaving. So that's why it says custom static site generator, because I actually wrote my own. In my defense, I was already actually a maintainer of a quite old static site generator, so I took it as an opportunity to basically ditch that old code and rewrite it from scratch. But yes, I did write my own, and it was a bit of yak shaving. My colleague took my Google Doc with the initial build instructions and then spent a few days converting it into Inkscape, so now it actually looks really, really nice instead of the very ugly job that I did in Google Docs. So we use Inkscape for that, and my custom site generator is obviously, is open source. It's built in Dart, so it's just available in the Dart package manager called Pub, but also as a standalone exe, like Go and Rust executables are. In terms of other things that we use, Markdown, GitHub Actions, those are proprietary, those aren't free. Audacity and Shotcut I've included because I made a build guide video, so to go with the manual. Some people are much happier watching videos, so I did a video and I use those tools. Again, open source audio editor, open source video editor. Nothing is perfect, and we are not perfect. We still use proprietary tools. So like I've mentioned multiple times, GitHub, we use Discord for our community and chat, Google Docs, Sheets, Slides, all that sort of thing for admin-y stuff, Shopify to actually sell our stuff. I did look into self-hosting the shop. I'm glad I didn't, because once we started getting sales, one of the sales was from someone in, I think, Los Angeles or somewhere else in California. My colleagues in California as well, so it was like literally like from say here to Melbourne selling something. There were 5 tax line items on the Shopify receipt. There was state taxes, county taxes, multiple city taxes. I am so grateful that it's Shopify, not me, who had to figure all that out. So yeah, I can't say I'm unhappy with that arrangement. The fun part, making music. So I got into this because I wanted to learn how to make electronic music. About 4 years later, I still barely make any electronic music. I barely know any music theory. The music I make, I do not share with anyone except my closest friends and enemies. And I won't inflict it on you today. But if you do make music, if you are a musician, hobbyist, professional, semi-professional, this is kind of like the feature set that you get if you use a picoTracker. I don't have time to go into all the details, but essentially, for those of you who are familiar with electronic music, it's what you might call a groove box. It's got 8 monophonic channels. It started off just being a sampler. Now it also has as of the version 2 beta that I've done recently, it has 2 synths. For those of you who were in the earlier talk here where they was mentioned like a Commodore 65, one of the new synths is called SID because it's emulating the audio chip out of a Commodore 64. The other synth is actually emulator of the OPL2/3 chips that were in Sound Blasters and Sound Blaster 16s and Adlibs, for those of you who remember the old DOS days. Now, it's not just about the picoTracker. It can actually be connected to anything that takes MIDI. We've got MIDI in and out, although, to be honest, MIDI in doesn't really work at the moment. It's on my immediate to-do list. TRS, which is like the serial connection, and USB as well. So it works really nicely to connect it with external synthesizers, drum machines, whatever, via MIDI. And I'll show that in a sec. This is what the tracker flow looks like. You basically, people say it looks like a spreadsheet. You essentially enter notes on steps. Those steps are quarter notes. I hope I'm getting this right. Yes. So that's in 4/4 time. That's 1 bar of 16 quarter notes, and you can also apply various effects on each step, and also via things called tables, which are kind of like sped up commands that apply to each step. Now, when I mentioned I was happy about having the remote UI, one of the reasons is, to be honest, completely self-promotional, because YouTubers love to have this sort of facility when they make videos. This was my attempt to try and make, I'm still in the middle of making a tutorial on how to use kind of like the more advanced MIDI features, but as you can see, it does make life quite easier for you, because you can have, this is an OBS, you can have the interface, you can have like a little webcam capturing like me that's showing just the MIDI module next to the picoTracker. You can have some blatant self-promotion logos. So it makes it much easier rather, because if you try and video this, especially these screens are very, it's not hard, it's a bit hard to see here, they're very bright. And getting the contrast when you're pointing a camera at it is a bit tricky. Now, I'm hopefully going to be able to load here in a second or two a YouTube clip of an actual musician. He goes by the performance name of Floyd Steinberg. Oh, I'm really hoping it loads it. When I tested it took a few seconds. Who did a video about the updates we made to the version 2 of the picoTracker PCB and firmware. And I was hoping to show you this. Please load. Come on, Wi-Fi, please. I'll give it a couple more seconds, then I might come back to it. And he is an actual musician who releases music. And so I was hoping to play you a little clip from that video to give you a sense of the kind of, oh yes, it's coming, that can be made with it. Come on, you can do it, yes. So here you can see him playing, the picoTracker is actually connected to his synthesizer keyboard, so the drums are samples that are playing on the picoTracker itself. The picoTracker is sending MIDI to play kind of like the bass, sort of like a bass line on the synthesizer, and then he's jamming over the top of it when playing himself as well. So I don't have much time, so I'll just continue on. The final part, the joys of everything else. These are all the awesome things that I like about the project that have happened, because we are open source. There have been remixes of the PCBs, we've had some contributors, I'd love more. We've had different case designs by early adopters. We've got like 150 people now on our Discord. That's not a huge amount, but for a very niche product, I think it's quite good that people have come along and created the community. I'm super stoked that we've actually been able to ship something that's been such a, after working for months on something, it's so nice to be able to like see packets of PCBs going out to people who have started like posting their build photos on our Discord. Now, this is my chance to spruik the project to you all. This is an Everything Open conference, so for anyone who doesn't have like dev abilities, if you are interested in this sort of thing, bug reports are an awesome contribution to any open source project. If you do have dev capabilities or want to learn, we've got a contributing guide, we've got a dev guide, hopefully explains well enough to get you started. It's not too tricky a process to set up. huge number of things in our issue tracker. A few are bugs, a lot are enhancements and feature requests that I'd love to get to, but I probably will be a very old person before I do. So I'd love anyone who wants to contribute, you're please more than welcome to join us. The more the merrier. And for those who would like to join, our Discord's a really friendly, nice place to come along and ask questions or chat about this sort of stuff. That's the QR code to join if you'd like to. And I just want to finish saying something that one of my favourite YouTubers does at the end of each of his videos. Share the love, share the knowledge. Knowledge is power, peace. And I think that's a really nice way to finish off any kind of talk or presentation for a community. So there's the link in the QR code to my talk. I appreciate you all coming here. Thank you. And I'll take questions because, like I said, the best one will get a full kit. So currently unavailable big kit of the picoTracker. Thank you.
Are you affected by the E9 errata on the new Pico?
Oh my goodness, you know about it. And thankfully we are not really. Like, you might have seen a little resistor hanging off the early prototype dev board. That was because we were just relying on that, but we literally just had to add one resistor in a new revision of the PCB, and that's the only effect that we've had on it. Otherwise, we're not affected, no, thankfully. Yes?
Hi, I was lucky enough to be in Gladstone to build one of these things. It was awesome.
Oh, yes, thank you.
So you're working on the 2350, looking forward to seeing what you can do in that extra RAM. My question is, what's your opinion on the RISC-V core in that chip?
I love RISC-V. I'm a big fan, but much to my chagrin, I have to admit, I have not even tried running the demos on the 2350 I have on the RISC cores because I've just been flat out trying to do all the bring up on our new dev boards. So I can't wait to try it out, but I can't say much about it except I'm excited that they included it because, yeah, like I am quite the fan of RISC-V, so I want to try it out ASAP. Yes.
Thank you for that. I'm just wondering if you can attach speakers directly to the unit to play sound. Is that theoretically possible? Actually possible?
100%. So what I didn't show was like, or I've shown very briefly, there's a 3.5mm stereo output. Like, it was meant actually as a line out, not as a headphone out. So I actually had to do some hacks in the I2S code to not deafen people when they plug their headphones in because it was supposed to be only a line out. So yes, it was intended as a line you can plug in into your stereo or whatever. But yes, now you can also turn down the level so you can plug just normal headphones in as well. Yes, but sadly no speaker. Yes.
You said, yeah, going from PC tracker software to the Pico was a challenge. Like, what particularly out of the software, like, was the resource-intensive part that makes it a challenge?
Math, for the most part. So we've only been able to use, there's no floating point unit on the 2040, there was on 2350, so we could only use fixed point. Thankfully, our GPT was mostly fixed point, and the synths we picked are specific, because there's a huge number of emulators, we picked the ones that were specifically already in fixed point, and yet, if anyone knows tricks to make fixed point multiplication fast, please come and see me because even then we're currently limited to just basically 3 synth voices out of those 8 channels because that's all the, and we have a whole core, overclocked core dedicated to just audio rendering, and currently that's all we can do even at fixed point, just because even fixed point multiplication takes a long time when you've only got a few thousand cycles to render one sample. Yes?
How did you go about deciding to make this your full-time job?
Oh, yeah, it was a bit scary. I was already like a contractor, so it wasn't just a complete jump into the dark. And basically, I had just the opportunity where like I finished up on a contract, and rather than going to look for a new one, I thought I like doing this more than any of the previous clients, the past contracts I'd worked on for the last few years, and I thought, why not try it? Plus, it was kind of like a good opportunity to try something new. Like I said, I was an EE by training. I only ever did software my whole career, and this was a chance to like work on something fun. And there seemed to be people, especially based on the really kind reception I got from last EO, that were keen to buy either the PCBs or like entire pre-made units. So we thought, oh, maybe this could actually even be a viable business while keeping it still like open source and trying to maintain like an open community around it. So hopefully that answers your question. Like it was, but it was a bit of a jump in the dark, to be honest.
And that's where we have to stop. So who had the best question?
Ooh. I think the person who asked about the picoTracker work that we had to do to make it work. So here you go. Hopefully